Hi, everyone, and welcome to another episode of the Data Standard Audio Experience. Today on our show, we have Daniel Gremmell, the head of data at Policy Genius. And today, we're going to be speaking about cluster techniques. So welcome to the show, Daniel. It's so great to have you today.
Thanks, Catherine. Pleasure to be here.
Yeah, definitely. And could you tell us more about your background and go ahead and introduce yourself?
Yeah, absolutely. So I am the head of data at Policy Genius. We're an insurtech startup. And prior to being the head of data at Policy Genius, I've been through a rather non-standard pathway to get into data science. Originally, my undergrad was in operations management. I subsequently got a master's degree in industrial engineering. Was working in pretty logistics and supply chain and operations-based industries pretty heavily for a few years. One thing that was constant through those is my use of math and statistics and different types of analysis to get to answers and results. And then eventually I made the shift over to data science. I also got a second master's degree in statistics, eventually with a focus in machine learning, which was super helpful in making that shift, especially with the rise of machine learning coming a couple years ago. And then from there, I started building out data teams for many different companies, including in publishing, at startups. I've worked in food, and then eventually made my way over to Policy Genius as the head of data. And as the head of data, what I oversee is data engineering, data analytics and analysis, and then data science and machine learning.
Yeah, that's fantastic. And it sounds like you have a lot of great experience and a lot of different things that you've been working on to get to where you are today. And today, the big topic is going to revolve around clusters. And so my first question to you is, what is a cluster and how would you define that?
Yeah, so I'm going to give you a super simple definition of what a cluster is in the context in which we've used them before. But a cluster is just a group of things. And the reason why, and when I say group of things, that can be customers, it can be like ticket groups, or it can be like almost anything that you want to group, you can group together using clusters. Most people use it for customers. That's usually the general consensus. It's how you group things together, but it can be any unit really. But most people, when they think of segmentation or clustering, they think of how they want to group customers together. And the reason why we do that is it can be a little difficult to think of each customer individually. And the theory behind segmentation or clustering in general is that if I can group together people or customers that are similar, I should be able to intervene with that larger group and expect a similar response from that group of people. So that's why most people cluster. It's just a way of like reducing, looking at hundreds or thousands or millions of customers down into a couple of core groups that are similar that you can then work on designing interventions across. So that's the definition of a cluster, just a group of things. Most of the time, people are customers.
Yeah, no, that's a great explanation. And how have these cluster techniques changed over the past few years? And how do you expect it to change maybe in the next coming years as well?
Yeah, that's a good question. It's changed in quite a few ways. So most of the base techniques for clustering have been pretty consistent over the past few years. You have things like k-means, you have hierarchical clustering. Those are normal methods that people have used for a while to cluster. You also have some more distribution-based approaches like Gaussian mixture models, and those have been on the rise for the past few. I mean, they're not new techniques per se, but they're more, they become more prominent with more difficult problems and different types of problems. Then there's been the invention of rather new clustering algorithms like your DB scans that solve a lot of like the weird shape issues that you run into with clustering. So for context, a lot of times if your clusters aren't spherical, you could run into a problem with trying to identify clusters. There's plenty of problems you run into where there's nonlinear shapes that you need to group together. And that's where like techniques like DB scan have popped up to allow you to have a more nonlinear approach and not have to worry about something being super spherical. Outside of that, those have been a lot of the movements in the clustering world. I would say over the past few years as well, especially with some of the research papers I've read, there's also been a movement, and this is what I've been getting excited about, and it's kind of part of your next question, but it's also been a movement in the clustering world towards more interpretable methods. So a lot of like tree-based methods, a lot of people have tried to use like random forests and whatnot to define clusters in general. And the challenge comes from just finding good groupings that are logical and make sense. We didn't talk about this in the definition, but normally when you cluster, it's a problem of trying to group together people and individuals, and you don't know if they really belong together. So you have to try to figure out if people belong together based on what you know about them. And that's where some of the complexity really comes in when you start to cluster is what should the groups be? And do I have good definitions of groups? And then coming back to the interpretable methods, like I was talking about a second ago, one thing that gets a little hairy with clustering sometimes is trying to decide on the number that you need and if these people really belong together. And with some techniques, you get tons of overlap or really low quality scores. And with more interpretable methods that have come out over the past few years, especially like tree-based methods, you can actually get pretty decent quality scores in your clusters. And they're also much more explainable. So this kind of ties back into some of the machine learning pushes over the last few years of just having more interpretable models in general. And clusters are no different, right? You want to be able to explain how your cluster is defined, who's in it, and you want it to be separable enough that you can explain it to somebody and they don't have to have a degree in data science or read through your code to figure out what's going on there. So those are some of the techniques over the past few years that have really emerged in the clustering world. And really, if you think about why we cluster, it is to try to handle groups of customers in different ways. On the website side, a lot of this is also pushed towards a more like lower level degree of personalization. So normally with clusters, what you would do is like launch different interventions towards different groups of customers. And that's really like the definition of what personalization is, right? You try to figure out which customers group together and then intervene with that group. Well, with the rise of like A/B testing or web testing in general, and more startups out there, the idea of just having a finite amount of clusters is something that is also becoming somewhat outdated from a like website design perspective and how you personalize folks, meaning that things like reinforcement learning are kind of making using clusters on your site a little bit obsolete, if that makes sense. Still relevant for the marketing world and like thinking about a conceptual profile that you're looking at. But as far as like how you might intervene with somebody through a process, there are machine learning tactics and deep learning tactics that have come up that are actually even more personalized than using clusters and also quite powerful. So I hope that answered your question about the changes over the past few years.
Yeah, absolutely, it did. And it's so interesting to hear your perspective on this. And with a lot of the work that you're doing with revolving around clusters specifically, I'm sure there's a lot of challenges that might arise with the work that you're doing with all the projects that you're working on. So what do you think has been the biggest challenge for you or the people that you've worked with revolving around clusters specifically?
Yeah, I would say there's definitely a few challenges that have popped up. The first challenge is one I kind of already alluded to, which was really trying to get down to the number of clusters that you should have and how they're defined and be able to explain that to somebody. That's like challenge number one when it comes to unsupervised learning in general. So the number of clusters you pick is somewhat subjective. There are ways to get there, but it's also somewhat subjective, right? And my rule of thumb is always we want to maximize our quality score, but also have a reasonable amount of clusters that people can like interpret. That's the whole point of like grouping people together is you want to be able to interpret those groups. So if you start getting into the realm of like, oh, I have like 100 clusters, you're kind of like getting to that level of I should just start looking at user level data, customer level data, and operating off of the customer versus like a bunch of different groups that I'm getting. So my sweet spot is like usually a low number of clusters, somewhere between like 8 to 20 or something. Maybe 20 seems a little high in some cases, but like you want people to be able to interpret them when it relates to like targeting, profiling, and other types of use cases in that realm. So that's always the biggest challenge is like, how many should you have? And the answer is somewhat subjective. There are ways to get there, but it can also be somewhat subjective. The second biggest challenge when it comes down to clustering is the explanation piece, right? Being able to explain your clusters to people and actually have clusters that are separable enough where your explanation makes sense. So with a lot of methods, like let's say K-means as an example, a lot of what I ran into, especially with some of the data that I've worked with, is the definitions of who's in those clusters is really hard to deduce. And so what a lot of people will often do is like they'll model it, like they'll fit like a K-means model on top of that, and then they'll fit some other type of model to try to explain what's going on in there. And if you kind of visualize the output of those clusters and look at things like a silhouette score or something like that, it turns out sometimes those methods in some use cases don't always have like the highest quality score. They're not as compact and they're much more difficult to explain, and they contain a lot of parameters that tend to overlap. And also there's no concept of like variable selection. So you're not really sure what matters and what doesn't matter. And this happens in like my world a lot in that you might have quite a few variables you want to try clustering on. And sometimes it's hard to deduce out what you should put in or keep out. And for something like K-means, the more dimensions you put in, the more difficult it becomes to get a really good model. So the ways around that and some of the ways that we've solved that have been to use some of the more interpretable clustering methods that rely on trees. And so they kind of invert the process where instead of clustering on data and then modeling on top of that, you actually reverse that where you model first and then cluster on the leaves of like a decision tree or something like that. And what that's really powerful and helps you do is really maximize that silhouette score, have clusters that are easily well defined. And then when you post apply a model back on top of that, you can really see the decisions and how those clusters were split and why. And it makes for an easier story to tell to your stakeholders across the org.
Yeah, fantastic. Thank you for sharing the challenges that you have faced, by the way, just because I think that's something that not enough people from different organizations discuss, or just the challenges and sometimes the failures that happen. But yeah, so thank you so much for sharing. And my final question to you is just about the general future of how you see clusters impacting the industry today. How do you think clusters will be used, maybe in industry or academia or in anywhere in tech in the future? How can it change and impact the world today?
Yeah, for sure. So I would say over the past few years, clusters have been heavily used for profiling, targeting, and some more of the qualitative aspects of running a business, meaning that like you don't always fit a cluster model and load it somewhere to call against or something of that nature. That has started to shift, I would say, over the past few years into as people get more and more into like website personalization or process personalization or some other type of personalization tactics. What you do see are clusters being applied to those personalization tactics. So it's kind of like the level personalization, right? So if you have a website right now, what is probably happening is you might have like one experience for everybody, or you might treat everybody kind of the same through that process. Your next level up to that is like you start to segment by attributes that you kind of know about. Next level up from that is you kind of define clusters, and then you start scoring customers against those clusters. And then you start tacking on different pathways or experiences to those clusters to see what works best for different groups of people. And then kind of like the last pathway in personalization is like the hyper personalization of I'm going to react differently to every single customer based on a wide sweeping array of features and what works best against that customer configuration. And so clusters kind of fall at that like tier right before you get to the super low level amounts of personalization you can do with like reinforcement learning. So you have a finite finite amount of groups to work with. You can design experiences for those groups, and then you can basically personalize against them. And so that's what I see happening more and more in the tech space. And it's something we'll probably keep seeing over the next few years when it comes to website personalization is those that aren't ready to commit to things like deep learning or reinforcement learning. Clustering is the next logical place to go so that you can provide a more tailored experience for folks, or also provide different pathways that have a higher chance of meeting the needs of your customers that are coming to your site. I'm trying to think of anything else that pops in my head when it comes to clustering, but that's probably the biggest impact I would envision in tech over the next few years.
Yeah, no, that sounds like a super interesting innovation that we'll be seeing as of right now and in the coming years as well. So yeah, where can everyone find you online to connect with you?
Yeah, so I'm on LinkedIn, super heavy, so you can pick up on LinkedIn.
Thank you so much, Daniel, for joining the show today. It was such a pleasure to have you. At the Data Standard, we're trying to build a community of data experts, data thought leaders, data enthusiasts, just so everyone has a place where they can all network and collaborate with each other. So what is something the community can help you do?
Yeah, so I would say two things. Number one, always open to networking with other leaders in the data space to learn more about what works and hasn't worked for their teams. Kind of like we're all learning, and so it's great to learn from others that are in similar positions and roles. And the second thing is, if you go to polished2genius.com and check out our open roles, we are always hiring people for the data team. So if you're interested in either leadership roles or IC roles, we usually have both of those available. So feel free to check them out and then get your resume over if you think you're a fit.
Yeah, perfect. And to our audience, for more information on the Data Standard, you can find us at www.datastandard.io, as well as on our LinkedIn and YouTube channel. And thank you so much, Daniel, for joining me. It was so great to have you on the show, and we hope to speak to you again soon.